Okay, we got the layer for the land cover. We basically just reclassify it, and after reclassify it, we need to isolate land cover within flooded land. So we only want to analyze the land that has been flooded. If we multiply the reclassified land by the flooded land, every pixel that has a value of 1 flooded land will be retained, and every pixel that has a value of 0 not flooded will be not shown. So that we showed previously is spatial analysis tools that we will do times again, spatial analysis for the times, and we will close this out and go back to tools, and we will type times. This time we will do the spatial analysis. So you see image analysis, so I accidentally I might did different. So this time the first one is reclassify land. It will be number 1. We don't want that one. And then the second one, it will be our flood land. And our output, the same. We will say final cover. And we will click run. So close the geoprocessing pane once it's done. Close. And now we will uncheck the collapse, and we don't have to see this. And uncheck the collapse, and collapse this, and flood the land. Flooded land is right here. Okay, and then we will change this final cover into isolated land cover. We rename it, and then we will do the symbology, and then we go to appearance. We select this layer, and we go to symbology, and the label we will have to change it. So the first one, 0, that will be our water, and the 1 it will be develop. Oh, we have to double check. So the no data. Okay, no data. That's fine. So, 0, it should be not water. So 0 will be no data. So I change it into that empty. Label 0. I would just not flood. Not flooded. Not flooded. Okay, number 1, that will be our water. Water. And number 2, that develop. Number 3, it will be barren. Number 4, it will be shrub. And grass. And down there we will have a wetland. Okay, wetland. Wetland. Wow. Okay, so water, we would just change it into water. Symbology. Okay, symbology. Oh my god. Water. Okay, so this will be water. And developed, we can just use it red. Okay, barren. The same way. Use this color, and shrub. This was fine. Wetland, and we'll use a little this dark green. Okay. So, because we are in a large scale, that's why you see those mosaic. Alright, then we will have, we calculate the percentage and the acreage for our flooded land. So we will continue to calculate it. Now, follow the same steps. We will have, let's see, that we will do the quantitative assessment for this. So quantitative analysis that we will do making decision dealing with those damage that require the quantitative assessment of the acreage and the percentage. So the developed and different land used in Key West, so that how the wetland destruction may have a greater long-term impact on the recovery of the economy of the environment. So to determine the percentage of each type of land cover, we must know the following information. So the total number of pixels, the number of pixels for each value. And now we will use this formula number of pixels for each classification total account and times 100 to calculate the percent of each type. So we open this attribute table and then accept not flooded, and we will close this out and right click on and open attribute table, and we will go to 2 and 3, 2, 3, 4, 5, 6. Okay, with those not flooded. Okay, and then we will do let's go to analysis tools and summary statistics. So we will search summary statistics, and the first one, analysis and input table, that we will have isolated land cover. Alright, field. If I do count, so that should be an issue because we only want the selected one, and we have to minus the one we don't want. Okay, and final. Okay, that's fine. We click run. We selected those. And then I can do another one. So I highlight it and then go to count, summarize. There. Summarize. Click close it out. Okay, summarize. Right, instead of statistics. The same, count, statistic type. Let's see if they are the same number. Open. Okay. Okay, frequency is 5. 1, 2, 3, 4, 5. Okay, perfect. Okay, 9173. Alright, so I will go to open attribute table. Oh, this one I need to 1, 2, 3, 4, 5, and then I can just do summarize. I need to uncheck this and do sum count. It's the same. And then I will just sum again. Alright. That for Wilma, we will have total, and we will have to calculate that, and we will do acres and percentage. So now the counts, we have the number, and we will do percentage now. Alright, so we will see this statistics, click open, and yep, it's the same value. And which we will do next is for this table that we will do count, sum of the count we did, and on this we will add a new attribute table. So go to field, and we will field view, and we will say this will be percentage, and same percentage, and it will be float. So when we change it to float, and we want the numeric is 1 decimal point. There, and numeric, and it's just 1. Click OK. And so then we are done. Save it, and back in here, and we will calculate it. Okay, so gonna right click on it. So that we will have is go to field calculation, calculate field, and the first one, yeah, isolated land cover percentage, and Python 3, and this one will equal, we will use count divide by our cell number is 9, I forgot. So it will be 9173, okay? So total is 9173. 9173. Okay. 9173, and we have to times 100. Then we will run. Okay, calculate failed. Oh, because I had a 2 times symbol. Run it again. There. Okay, so our water is 7.7, and then we have 60.5, 2.6, 7.2, and then 12.7. So, which is perfect, and we will have to do the acreage. So, and I will do, actually we don't have to do the other one, but here I'm gonna go back to map and clear selection. That the one with the null data could be an issue, but it's okay. We will do quantitative assessment for the acreage now. So the final step in the analysis, we will calculate the acreage of the flooded areas. So this information will allow the other team and other government agencies, insurance firms to make damage assessments. So we will change the value of the pixels from the meters to feet and spatial dimension of the pixels that has been. So and still it is in meters. So to calculate that, the thing is, so each cell has dimension of this. It's 30 times 30 meters. That is 90 square meters, and acre is 4,046.6 meters. So everything remains the same. And the same steps we will do is we will open this here, and we will click here. For the table option, we will add a new field. The new field will be acres. And acres. And this one will be the same float and numeric. And the same as just 1 decimal point. And once we have that, we have to save it, and we will back in here. Okay, we back in here now. We have an acreage, and for acreage we will do calculate field. For calculate field, land cover acres Python 3. So we will have the count. We have to times count times 900 and put parentheses. And we divide by 4,046.68 because we have to convert it to square feet. That we have to divide it by the square meters that we can convert, and we will run. So acres, we will have yeah, well, and it's similar value, but could be a little issue here. All right, so now we have everything, and we are ready to move on to present our data. So sum of counts, I already have the sum of counts, which is 19173, and acres we did was times 900. So let's calculate it again. Something is a little weird here. 91